Welcome back, everybody. So I was just talking about this to my class in here. Hopefully this is a good review of section 7.1 to 7.4. Remember, again, we have our chapter 7 test somewhere along the line pretty soon. Not pretty soon, but we still have to do section 7.8, 7.7 and 7.8. Now, we'll do section 7.7 today and tomorrow. We'll do section 7.8 on Monday, and then we'll test by next Wednesday. Okay? So it's next week. It's coming around the bend. So it's there. That's why I wanted to do this exponent review so that it keeps it in our brain. So let's go over this. Number one here, we got 1 over -8 or -1/8. Remember, no decimals, only fractions, no decimals. Number two, that 5 to the 0 power. What is anything to the 0 power? What is anything to the 0 power? 1. Anything to the 0 power is 1. And then we've got -4 squared. Now, does that -4 go down into the denominator? No. Only the negatives in the exponent would go down into the denominator. So that's just positive 15. And then number 3 there, you got to just kind of make them happy, right? All negative exponents move down or up accordingly. So therefore, the negative exponent in the A moves it down to the denominator. The B and the C, the C moves up, the B stays where it is. And then -4 obviously stays on top. This is just a negative number. What do we do when we're multiplying with the bases? Like in number 4. What do I do with the exponents when I'm multiplying the bases? Okay, add them together. So in this case, A to the 5th and A to the 6th make A to the 11th. Don't combine it with the B. Number 5, same thing there. Just watch out. X to the -2nd, +3rd, -9th would turn into X to the -8. But can you ever leave a negative exponent in an answer? No. So that's to turn into 1 over X to the 8th. Check your papers right there. Make sure you do not leave X to the -8th power. Make sure you turn into 1 over X to the 8th power. Number 6. That one, remember, power to power. Whenever I've got an exponent on an exponent, you multiply those things together. So it should be y to the -10th times y to the 3rd, which eventually turns into y to the -7th. Look at your papers. Did you leave y to the -7th? Turn it into 1 over y to the +7th. Looking at 7, 8, and 9 down there. Again, watch out right here. Folks, we distribute this power. Okay, distribute that power. That's 5 to the 4th and y to the 3rd to the 4th. What is 5 to the 4th? A really big number. 5 to the 4th power is 625. And then we've got y to the 12th. Same type of thing there. Let's turn your phone off now. Thank you. -4 to the 3rd power is -64. A to the -9th because it's -3 times 3. And then b to the 2nd to the 3rd is b to the 6th. A moves down to the denominator because it's a negative exponent. Leave the -64 on top because it's just a negative number, not a negative exponent. Number 9 here. Don't forget to distribute the power x to the 4th, y to the 4th, and then subtract the exponents. Because remember, when we're dividing, we subtract the exponents. That should be x over y, or sorry, x times y to the 4th. 5 minus 4 is 1. 8 minus 4 is 4. Here's 10, 11, and 12. Ooh, looks like 13, 14, 15, kind of blurry there. Here's 10, 11, and 12. We distribute the power of 2 in. We get 4, x to the -10th, y to the 8th. Now, here, again, this is not 6. Check your papers there. That's not, do you don't have one of these? You never picked one up there. Okay. 3 to the 2nd is not 6. 3 to the 2nd is 9. And then x to the 8th, y to the -2nd. We combine here. That would be my x to the -2nd. We combine here. This is y to the 8th and y to the -2nd. We get y to the 6th. And then 9 times 4 is 36. Move the -2nd to the bottom, x to the +2nd. Remember, when I've got a fraction, I've got a negative exponent on a fraction, we flip the fraction. So 4 over x squared should be 16 over x squared. Number 12, I would simplify before I evaluate here to make that x, remember, flip the fraction, x to the 5th, y squared over 2x to the 3rd, and then I can simplify here. That's just an x squared on top. So x squared, y squared over 2. Bring that all into the 3rd power. That should be x to the 6th, y to the 6th. 2 to the 3rd is 8. So x to the 6th, y to the 6th all over 8. Looks like that's really blurry. So I'm just going to show, I think I still got it up here. Yeah. Oh, it's still really blurry. Okay. I'll just go back here then. Number 13 is 18x to the 4th. Number 14 is 48m to the 7th, n to the 4th. And number 15 looks like 4b to the 2nd over negative 3a. 4b to the 2nd over negative 3a. Again, for those ones, when you multiply, you got to bring in the exponent here for that 3x, and then you multiply together. 2 times 9 is 18. X squared and x squared make x to the 4th. We bring in here this positive 16, m to the 6th, n to the 2nd. Maybe. And then this stays the same. 16 and 3 make 48. M to the 7th, and to the 4th. We divide here. Watch out for number 15. I know you can't really read it right there, but watch out for number 15. You have to divide 12 over 9 to get 4 over negative 3. And then you have a to the 4th over b squared. Or sorry, a to the negative 1st over b squared. Or times b squared. And then you move the a down to the denominator. Any questions on that review assignment? Okay. Let's talk about section 7.7. Now, here's what's going to happen. Today and tomorrow, we're going to talk about section 7.7. Hopefully tomorrow I can get your quizzes back in your hands. You can take a look at them and see what's going on. I think I finally got people caught up on that section 7.1 and 7.4. Remember, if you want to retake that, you guys let me know soon. Like today or tomorrow. You guys really burns me up, you know? I'm a lot. Thank you. Oh my gosh, is this still up here? Wrong by him. My count color. But section 7.7 is today and tomorrow. Section 7.8 is going to be on Monday. And then, honestly though, section 7.7 and 7.8 are kind of like the exact same thing. All we're going to be doing in section 7.7 and 7.8 is learning how to multiply with polynomials. Then on Monday, I'm going to give you your practice test, and that's going to be homework for Monday night. We'll go over it on Tuesday, test, Wednesday. Okay? But we've got 3 days to learn how to multiply with polynomials. 3 full days to learn how to multiply with polynomials. Now, multiplying polynomials consists of multiplying monomials times monomials, monomials times binomials, binomials times binomials, trinomials times trinomials. We've got a bunch of different nomials, right? And we're going to multiply all of those together, okay? All right. Now, remember, based on our exponent review, that when we're multiplying with like bases, we add the exponents together, right? So like if I had x to the 3rd times x to the 2nd, it would be x to the 5th power, right? X to the 2nd times x to the 3rd would be x to the 5th power, 2 plus 3 power. So x to the 5th. So let's remember that when we try to do multiplying with monomials. Now, there's no need to do any sort of distributive property. Do the parentheses really even do anything right here? No. What operation is always in between 2 parentheses if nothing's written? Multiplication. So really, this is all just multiplication. I could rewrite this to say 6 times y to the 3rd times 3 times y to the 5th. Now, we know that we can multiply in any order and it's not going to change the outcome. So what I can say now is, let's multiply 6 times 3. What is 6 times 3? 18. And then we can multiply y to the 3rd times y to the 5th. What is that? What's y to the 3rd times y to the 5th? Y to the 8th. Remember, add exponents when multiplying with bases. Okay, so when you have a monomial times a monomial, you're basically going to just multiply the common pieces together. You're going to multiply the numbers together, and then you're going to multiply the letters together. Okay. All right, let's keep it moving. Take a look here. These are two monomials again, right? Not changing anything here. Two monomials multiplied together. So that just means that I can multiply the numbers together. Well, what's 3 times 9, folks? 27. Okay, m to the first times m to the second. What is that? M to the third. M to the third power. And then I've got n to the second, n to the first. Oh, that's another third power. And that's my answer. So you just got to multiply common pieces together when there's just a monomial and a monomial. See, it's important to be able to identify what we've got so that when we have, like that's why it's so important to know monomial, binomial, trinomial, because now we're going to be using that as our rules to tell us how to multiply. All right, so let's do one more. Why don't you guys go ahead and try that one on your own? We've done 2 of them. You do the third one. All right, so what's the number that should be sitting out in front? 10. 2 times 5 makes 10. Now, is there any other r to combine it with? No, so we just leave r squared. And then what's my power on t? T to the 4th power. And that's my answer. Yeah.
For those, do you have to put it in order of like the greatest?
No.
Okay.
No, there's no standard form here because there's no plus or minus sign for it. It's just one term. Okay, so I hope we can see that monomial times a monomial is not very difficult. It's pretty simple. It's very straightforward. Just multiply all the numbers together and then multiply all the common letters together. And I can combine with any powers that I want. Like if I wouldn't be able to add those things together, but I can multiply them, right? You can't add those two pieces together, but you can multiply those two monomials together. All right, so let's kind of ramp it up a little bit. Now let's say a monomial times a trinomial. Now, we had never recognized that it was a monomial times a trinomial, but haven't we done the distributive property before? So we've done this before, but we just haven't called it, a monomial and a trinomial, right? It's just the distributive property. So let's do it. Go ahead, do it. We distribute this 4n. We got 12x squared, 16x, 32. Yeah. Just quite simply distribute. Now, I'll tell you this. From here on out, this whole guy to know that for all ever and ever for multiplying, it's just the distributive property. When you have multiple terms, you're just going to be using the distributive property over and over and over again. Let's try it again. See, the issue here, though, now is we've got not just a single constant monomial on the outside. It's now a multivariable thing going on. I've got P's and Q's. Still just do the distributive property. Okay. Let's distribute it in. Okay, but now we have to be just a little bit more careful. I've got 6p cubed times 2p. 6p cubed times 2p. Well, I'm going to take the 6 times the 2 to get 12. I'm going to take, what's p times p? P to the second. And then I've got a q sitting in there as well. Okay, that was 6p cubed times 2p. And now we take 6p cubed times q. Well, The 6 doesn't have anything, I mean, there's a 1 sitting out front, so 6 times 1 is 6. P times, well, there's no other p's to combine it with, so I just bring it over. But then I have q times q, which is q squared. And again, that's not q plus q. That would be 2q. Q times q is q squared. Q plus q is 2q. And we're multiplying here, not adding. Questions about that? And that's it. We leave it like that. Unless we could possibly try to simplify it down by combining like terms, but these aren't like terms, so I can't combine them. Okay, let's try this one. 1/2 x squared y multiplied in. So again, I see a monomial sitting on the outside. Yes, it looks like a very complicated monomial with a fraction and everything, but it's still just a monomial sitting on the outside, isn't it? 1/2 x squared y is just a monomial, single term, no addition, subtraction. So let's bring it in. 1/2 x squared y times 6xy. Well, 1/2 times 6 is 3. X squared times x to the first is x to the third. And then y to the first and y to the first makes y squared. See, if you take it piece by piece, it's not too bad. You just have to go slow, take it piece by piece, take it bit by bit. Okay, now let's distribute the other one. I've got 1/2 times 8, which is 4. I've got x squared times x squared, which is x to the fourth. And I've got y to the first times y to the third, or sorry, excuse me, y to the first times y to the second to get y to the third. And I leave it like that because those are not like terms. So again, just the distributive property. Just the distributive property, but taking monomials, multiplying them together, using just the distributive property. Now, everything that we've done so far up in today has been a monomial times something. A monomial times a binomial, a monomial times a trinomial, a monomial times a monomial. So what if we expand that a little bit more? What if we have a binomial times a binomial? Let me show you this. Okay, to multiply a binomial times a binomial, 2 terms times a 2 term, right? 2 terms times a 2 term. You can apply the distributive property more than once. Let me show you how. Do we all agree that x plus 3 is a binomial? 2 terms. It's a linear binomial. And a linear binomial. I've got 2 binomials. They don't have to be linear, but I've got 2 binomials multiplying them together. Well, I can use the distributive property for both pieces. Let me show you how. I'm going to take this x and I'm going to distribute it into this x and this 2. Let's do that first. Let's distribute the x into both pieces of my second binomial. What is x times x? X squared. What is x times 2? 2x. Plus 2x. The symbol, the operation is the symbol. You know, these were positive numbers, so it's just a plus each new term. And now what we do is we're going to now take the 3 and bring it in. Now, I don't want to confuse you with so many arrows on the top, so I'm just going to put them on the bottom. I'm going to distribute into here, and then I'm going to distribute into there. Okay. 3 times x is 3x, a positive 3x. 3 times 2 is 6. So I just applied the distributive property twice. Now, can I combine like terms with this problem? In the end, can I combine like terms? Are there like terms? Yes, the x's. I can combine these x's to leave us with x squared plus 5x plus 6. And that's my answer. So when you want to multiply 2 binomials together, you're going to basically do the distributive property twice. Now, there's a fun, catchy way, I don't know about fun, there's a catchy way to remember what you're doing there, and it's called using the FOIL method. Okay, it's called using the FOIL method. I don't know where my F got lost along the way here. There we go. But it's called using the FOIL method. Okay, man, anybody that's passed Algebra 1 is going to know, oh yeah, FOIL method. I remember the FOIL method. I know how to FOIL those two binomials together. Okay, what does that mean? That means that you're going to multiply firsts together. You're going to multiply outers together. You're going to multiply inners together. And then you're going to multiply lasts together. You see that, how that works? First, outer, inner, last. FOIL. It's just a mnemonic device. You guys know what a mnemonic device is? A way to remember something based on the first letters of those things.
PEMDAS.
What's that?
PEMDAS.
PEMDAS is one. You ever hear the mnemonic device Holmes? Huron, Ontario, Michigan, Erie, and Superior, the 5 Great Lakes. Make the word Holmes. Huron, Ontario, Michigan, Erie, and Superior. There's other ones. Isn't there one to remember, like the converting kilo, hecto. Yeah, that. Yeah, I don't see it. But that's a mnemonic device. This is just a mnemonic device. First, outer, inner, last. FOIL. First, outer, inner, last. Now, what does that mean? That means you're going to multiply the first terms together. Well, what are the first terms? X and X. Then you're going to multiply the outers together. The outers are X and 2. Then you're going to multiply the inners together. 3 and X. And then you're going to multiply the lasts together. 3 and 2. And then in the end, you're just going to add everything up. Combine all like terms. Okay, you're just going to add all of those pieces together, which is going to leave you with an x squared plus 5x plus 6. Guys, I'll tell you what, everybody always like, oh, FOIL method, oh, that's so fun, FOIL method. Guys, the FOIL method is just the distributive property used twice. That's really all it is. So if you don't even want to remember this FOIL thing, you don't have to, as long as you do the distributive property correctly. Twice. So let's try it. Let's multiply these two things together. S plus 4 and S plus 2. S plus 4 and S plus 2. All right. So I'm going to use the FOIL method. First, S times S. What is S times S? S to the second. Outer. S and 2. What's S times 2? 8? I see you raising your hand, so I'll me. 2S. My inners. 4 and S. What's that? 4S. And here's my last. 4 and 2. 8. First, outers, inners, last. Basically the distributive property. Distribute the S in, distribute the 4 in. And now I just combine like terms in the end. My answer is S squared plus 6S plus 8. That 2 and 4 just combine together to get the 6. And that's my answer. S squared plus 6S plus 8. Again, it's just the distributive property. That's really all we're doing there. I like to think it's like a FOIL man. See how it kind of makes a face? Here are his eyes. Here's the nose. Here's the mouth. Eyebrows. See it? Okay. I know. He needs a little trim on his eyebrows there. All right, here we go. X minus 6, X plus 3. Now, we just have to be careful when there's minus signs just in case there's any pluses or negatives going on in the answer. So let's see. Let's multiply this together. For this one, I'm going to use the distributive property method just to show you how they differ. Yes, I'm going to put your phone away. And let's put it in your bag. Let's put it in your bag. Okay. X minus 6, X plus 3. So let's distribute that. Let's say X times X. What is x times x? X squared. X times x is x squared. Be careful with that. And then we take x times 3. What is x times 3? 3x. And it's a positive 3x, correct? And now let's distribute in the negative 6. And again, I'm talking about a negative 6. Negative 6 times x is a minus 6x. Do you notice how the sign became the operation? Negative 6 times x is a negative 6x. So it just becomes a minus 6x. Negative 6 times positive 3 is a negative 18, minus 18. And now we combine like terms in the middle. We got an x squared minus 3x minus 18. Questions about that? Okay, let's do a more difficult binomial. Okay, these are no longer just linear binomials. These are quadratic binomials. So how does that change things? Well, the only thing it changes is the difficulty of the multiplication, not necessarily the method, just the difficulty. So let's distribute again. Call it our first, outer, inner, last. First, 8m squared times m squared. Okay, what's that going to be? 8m to the 4th power. 8m to the 4th, good. 8m to the 4th power. My outers, 8m to the 2nd minus and a negative 3n. Okay, now I've got 8 times negative 3. Yes, I do consider that a negative 3. 8 times negative 3, that's a negative 24. And then I've got an m squared and no others to combine it with. And then I've got an n over here with nothing else to combine it with. So the outer terms come out to be a 24 m squared n. Now we distribute in the inners. I take the inners here, negative n times m squared. And I always like to go in alphabetical order, so I'm going to make the m comes first. Minus, because one's negative, m squared n. There's no numbers to put in front, but I have variables that I've got to just put together. And then I've got negative n times negative 3n. These are my lasts. Negative times a negative, negative n times negative 3 makes a positive 3. And then n times n gets us n squared. Are there like terms in this one? Yes. The m squared n's sitting in the middle. This piece, those are like terms. So I'm going to say, leave my first term. I've got a negative 24 and a negative 1 to make negative 25. M squared n plus 3n squared. Questions about that one? Yeah.
You wouldn't add the exponent and multiply that, would you?
We did. Wait, you mean at the very end?
No, for like the 25m, would that be a 4?
No, because that's adding and subtracting at the bottom. Because this is subtracting, so you don't change the like term. The like term stays the same. Okay, now those three problems were all binomial times a binomial. The FOIL method is only for binomial times a binomial. So what if we have more than that? Okay, or what if we have something squared, something like this? Let me show you what we do here, guys. Please, everybody, pay attention right now. Can we like wake up a little bit? This is very crucial here. I've got x plus 3 squared. Never, ever distribute the power. That does not, don't even write that, don't do that. Never, ever distribute the power. You can do that on those exponents where it's just multiplying in the middle. Is this just multiplying in the middle? No, this is adding. You can never, ever, ever distribute that power like that. So how do we simplify it? Well, if it's x plus 3 to the second power, that's like saying x plus 3 times x plus 3. That's x plus 3 to the second power. So what is that implying that we do? That means we have to FOIL it. That means we have to multiply these two binomials together. All right, so let's do that. My first x times x is x squared. My outer x times 3 is 3x. My inner 3 times x is 3x. My last 3 times 3 is 9. Now, what is coincidental of these problems has been not so coincidental, it happens every time, but what is unique about these problems is that the inners, the things that you're going to combine right here, are always going to be the same. Whenever you have a binomial squared like that, the inner two values are always going to be the same. So my final answer is going to be x squared plus 6x plus 9. Okay. Let's do another one of those. Let's do one with a minus sign now. Please, please, please don't just say x squared plus 25. It doesn't work like that. You can't just square both terms in the middle. You must multiply with two binomials. What does that mean? That means I've got x minus 5 times x minus 5. Multiply the x's together. X times x. Multiply the x and the negative 5 to make negative 5x. Don't say plus a negative 5x. Just make it a minus 5x. Do the same thing with the negative 5. And yes, I am calling that a negative 5. Negative 5 times x, these are our inners, minus 5x. Negative 5 times negative 5 is a positive 25. And now we combine like terms in the middle. The first term will stay the same. The middle two terms, minus 10x, and then a plus 25 sitting out there. How do we feel about that? Okay, those are binomial times binomial. The last three examples that we have on our page are a little bit more difficult. Because you see binomials times trinomials now. Now, I'll tell you this, you're still just going to do the distributive property. That's all you're going to do. You're just going to do the distributive property. So let's try it. I am going to distribute this x into all three parts of my trinomial. It's like a super distributive property. Mega distributive, ultimate distributive property.
Make it 2x to the second.
No, this would, what is x times x to the second? X to the first times x to the second. X to the third. Because we add exponents. 1 plus 2 would get us to 30. And then we have x times 4x. 4x squared. And then x times negative 6. So negative 6x. Then we do the exact same thing with the negative 5. We do the exact same thing with the negative 5. Negative 5 times x squared, negative 5x squared. Negative 5 times 4x, negative 20x. Negative 5 times negative 6, positive 30. And at this point, we just combine like terms. At this point, we just bring down our answer. We have an x to the third. Make sure you're writing it in standard form. I've got a 4x squared and a negative 5x squared. So 4 and a negative 5 make negative 1, or just a negative x squared. We've got a negative 6 and a negative 20 to make negative 26. And then this plus 30 sitting out there on the end. Questions about that? Okay, let's do another one. We got 2x minus 5 times this trinomial. Yeah, do this with me. I'm going to bring in the 2x first. Okay, what do I get when I take 2x times negative 4x? Baker? Close. Negative 8x to the third. I have 2x times negative 10x minus 20x squared. And then I've got 2x times 3, 6x. Okay, we bring in the negative 5. Negative 5 times negative 4 plus 20x squared. Negative 5 times negative 10 plus 50x. Negative 5 times positive 3 minus 15. And at that point, I just combine like terms. Okay, I've got a negative 8x cubed, negative 8x to the third. I've got, oh, look at that. What happens with my x squared? They cancel. What happens with my x's? They don't cancel here. Plus 56x, and then minus my 15. And that's my answer. One more problem to do. Okay, now, we've taken squared powers, but what does it mean to raise something to the third power? Well, it's that thing times itself, right? You just write it 3 times over. People, can I just distribute this power in? No, I wish it, honestly for you guys, I wish it was that easy. It is not. You can't do that. Don't do that. Okay, so here's what we have to do. We've got to take this as x plus 3 times x plus 3 times x plus 3. You've got to multiply each of those pieces together. Now, this is going to require you to do 2 sets of problems in one. What does this mean then? Well, let's multiply this stuff together first. Let's just bring down our x plus 3. Go ahead and arrow that down. Just shift it right down. I am now going to multiply the x plus 3 times the x plus 3, a binomial times a binomial. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. So all in total here, I get x squared, a 6x, and a 9. And now this problem becomes like example A, in example 4A. Now this is a binomial times a trinomial. So what we have to do here is now distribute the x in. 6x squared, 9x. And then we'll distribute the 3 in. 3x squared, 18x, 27. And then we combine like terms one more time. X to the third plus 9x squared plus 27x plus 27. And that's my answer. Yeah, that's like the hardest it could possibly get. Okay? honestly, example 4, all of example 4 down there, the binomial times the trinomial, all of that stuff, that's difficult stuff.
Yes, I screenrecorded it. Really? No, it got someone, they recorded it so many times. It got-